Hi everybody. So in today's video, we are going to be going over some review notes about the two types of graphing of inequalities that we've been learning about so far in this unit. So the first type of equation that we've been studying is what's called standard form inequalities. When you're looking at a problem, you're going to know that this is a standard form inequality because the x and the y are on the same side of the problem. So you'll see here, you can see that the x and the y are on the same side of the problem. They're both on the left side of the inequality symbol. The second type of inequality that we're going to be looking at today is what's called slope-intercept form of inequalities. And when you're looking at a problem, you will know that it is slope-intercept form because the y is alone on one side of the problem. So you can see in this example, the y is all by itself on the left side of this inequality symbol. This is going to be slope-intercept form. Now, our strategy for graphing these is going to change depending on which type of equation we're looking at. So let's talk about first the strategy we're going to use for graphing an inequality that is in standard form. Whenever we see an inequality that's in standard form, our strategy is going to be to find the x-intercept, which is the point on the graph where y is 0, as well as find the y-intercept, which is going to be the point on the graph where x is 0. Let's review how to find the x-intercept first. If we want to find the x-intercept, because we're making y 0, we can find that by sort of ignoring the term of the equation that has a y in it. So if we simplify this, we're really going to solve the problem negative 5x is greater than or equal to 30. Oh, I'm sorry. We're going to change that to an equals while we're solving this. We'll go back to the inequality in a second. So negative 5x is equal to 30. When we solve this, we're going to do that by dividing by negative 5 on both sides. When we divide, we get negative 6 for x. So our point on the graph, which we're going to add to the graph in a minute, is negative 6, 0. That's one of the 2 points we're going to use to make this graph. If we want to find the y-intercept, we're going to do that by basically ignoring the part of the equation that has an x in it. So that means we're going to be looking at 6y is equal to 30. If we divide by 6 on both sides, we're going to end up with y is equal to 5. So the second point that we're going to add to the graph in just a second is going to be 0, 5. Let's go ahead and add those points to our graph right now. So negative 6, 0 would be right here. And 0, 5 would be right here. Now the next step is going to be to draw a line through those points. But before I draw that line, I'm going to make a decision about whether it should be a solid line or a dashed line. I'm going to make that decision by looking at the inequality symbol. Because the inequality symbol has an underline, that means we do want the points that are greater than or equal to the points on the line. So because of the equal to, we're going to use a solid line when we graph this inequality. On the graph, I'm going to go ahead and draw in a solid line through those 2 points that I just graphed. Now, we also need to decide where to shade this graph. When our equation is in standard form, we're going to decide on where to shade by testing the point 0, 0. We are always going to use 0, 0 because honestly, it's just the easiest one to test. If you put a 0 in here instead of x and a 0 in here instead of y, the entire left side of this problem becomes 0 because anything times 0 is 0. We're going to ask ourselves, is 0 really greater than or equal to 30? Well, the answer is no, it's not really greater than or equal to 30. This is a false statement. Because that is not true, I want to shade the side of the graph that does not have 0, 0. Now, 0, 0 is that red point I just circled. So we're going to shade the other side of the graph here. We're going to shade away from 0, 0 because 0, 0 was not true. Now let's go back and talk about how we would graph this inequality if it was in slope-intercept form. We have a different strategy for this kind of equation because it's easier to find different things because of the format. In this equation, we're going to go ahead and we're going to identify the slope and the y-intercept. Now, the slope is always the number that's right next to x. So in this problem, the slope is going to be -3/2. As a reminder, only the 3 is negative, not the 2. And so when we graph this line, we're going to end up going down 3/2. Now, the number that does not have an x is the y-intercept. So the y-intercept of this equation would be 0, 7. Let's go ahead and add that information to our graph. So if I go to 0, 7, I'm now going to go down 3/2, down 3/2, down 3/2, until I fill in as many points as possible on this graph. Now I'm going to do exactly what I did in the other problem, which is decide if this should be a solid or a dashed line. Because it's a less than symbol, I'm going to use a dashed line here. And the reason I'm going to use a dashed line is because there's no equal to, there's no little underline underneath the symbol. So when I draw this on my graph, I'm going to go ahead and use a dashed line to connect these dots. The final decision I have to make, just like in the other problem, is where to shade. But we make that decision differently because in this case, we want to find all the y values that are less than the line that we just drew. If we ever see a less than or a less than or equal to, we're going to shade below the line because we want the y values that are less than the line. If we want to shade, if we ever see a greater than or equal to, we're going to shade above the line. So because we see a less than in this problem, we're going to shade below this line. We do not need to test a point. We know where we want to shade. And shading below this line would be this section of the graph right here. Now, as always, we need to be able to test to see if certain points work in these equations or not. I'm going to add a problem to the end of this worksheet just as a hypothetical. What if I asked you to test to see if the point -2, 10 is a solution of the system of inequalities? Now, we graphed each of these problems individually, but what if I had given you both of these problems and said, make this a system, graph them both at once, and find the overlapping shaded area? The first inequality would have been -5x plus 6y is greater than or equal to 30. And the second inequality would have been -3/2x plus 7. Y is less than -3/2x plus 7. Now, if I treated this like a system, then my graphing strategies would be the same, but I would need to graph both at once on the same graph and find intersection area. Find where those areas that we shaded overlapped. In this case, I'm asking you to test to see if this point is a solution, which means it needs to work for both of these inequality problems. To do that, I'm going to take the -2 and the 10, and I'm going to plug them in instead of the x and the y in both of these problems and see if I end up with a true statement or not. So let's start by testing this guy first. I'm going to have -5 parentheses -2 plus 6 parentheses 10 is greater than or equal to 30. Now, if I evaluate this on my calculator, I get 10 plus 60, which is 70, is greater than or equal to 30, which is true. That actually does work. So I'm going to go ahead and put a check mark there to show that that is true. The next thing I'm going to do is I'm going to test this equation right here. That means that I'm going to plug in the 10 for the y, and then I'm going to plug in less than negative 3 over 2. I'm going to plug in the negative 2 for the x, plus 7. Now, if I type this in on my calculator and I evaluate that, I end up with 10 is less than 13. What we need to do is we need to ask ourselves, wait, actually, 10 is less than 10. Oh my gosh, I almost did that wrong in my head. I'm so sorry. What we need to do now is we need to ask ourselves, is this true? This is not true. This is actually false. 10 is not less than 10. So because this is false, our final answer would be that this point is not a solution of this system. It does work for the first inequality, but it does not work for the second one. And therefore, it is not a solution of the system. Thank you guys so much for watching this video. The next thing you're going to do is you're going to practice all of the ideas that we've learned so far in 6.7 to 6.10. So you're going to practice doing problems where you're graphing one inequality individually, like we just did here, using the strategies that we talked about. You're also going to practice doing some systems of inequalities where you have to graph two at once on the same graph. And you're also going to practice testing to see whether some points are solutions or not, as well as doing a few modeling questions, which are word problems. Thank you guys so much for working hard today. Make sure you finish all of your stations, even the ones you don't finish in class, for homework, and I will see you guys next week. Have a great weekend.